So next up we have Nic Jansma. Nic is one of those performance vets who's been doing this a very, very long time, and particularly from the measurement side of things. Nic has been a huge part of Boomerang, which is the RUM library that powers so many, honestly, so many of the products that you see out there, so many of the RUM solutions you see has been driven by a lot of the work that went into that kind of stuff there. And they also tend to push the envelope a lot on what can be measured, and I'm thinking of things like rage clicks and all sorts of fun stuff that kind of came out of that experimentation and things like that. And so probably, again, nobody more appropriate to be giving a talk about modern performance metrics than Nic. So everybody welcome Nic on.
Hello, 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 hello. My name is Nic Jansma. I work at Akamai. I work on our mPulse real user monitoring product. And today, I'm going to talk about modern metrics. Once we get there we go, modern metrics. Okay. So, what is new in web performance these days? I want to tell you a little story about some metrics called the Core Web Vitals. Don't know if you've heard about them yet. There's this thing called largest contentful paint, cumulative layout shift, first input delay. Brand new metrics that Google's talking about. May be interesting, we should take a look at them. Is what I would have said in 2020, had this talk originally gone forward 2 years ago, but as we know, what happened was COVID. Let's rewind. Take another stab at it. Hello everybody, my name is Nic Jansma, yada yada. I'm here to talk to you about web performance and all this new Core Web Vitals. They may be affecting your search engine optimizations. Is what I might have said a year ago had we tried to give this talk a year ago. Thankfully, we are now here. The talk is actually going on. I'm very excited that we're actually doing it this year. So we get to talk about modern metrics, the exact same title of the talk that I've been wanting to do for the last 3 years. I put modern in air quotes because I feel like I could give this talk any year and the metrics will be modern. But what we're going to do today is we're going to take a survey of modern metrics. We're going to take a look at what we have available, which ones are interesting to you, to me, how you evaluate them as a website, as a large company, which ones of these metrics actually matter to you? Why should you care? I'm going to show you a lot of data. We at mPulse collect a lot of real user monitoring data, RUM data. And we have some interesting insights that I would love to share. But before doing that, I'm also going to talk about how data can be biased and how the data I'm going to present to you is through my view, through our vision. And you may or may not want to trust that data as a result. Or you may want to understand all the caveats of the data that I'm presenting. We're going to talk about what's the latest in all these metrics. Again, we're going to do a big survey of all the Core Web Vitals and how we see them through the RUM view. And at the end, I'm going to encourage you to take a look at some of these metrics yourself. And that's because this year we have less COVID, thank goodness. And by the way, I'm so excited to see everybody here. I'm just very, very excited to be in front of you. Okay. So, modern metrics in the year 2022. What is a modern metric? We have Core Web Vitals, CWV. We have LCP, largest contentful paint. We have CLS, cumulative layout shift. We have FID, first input delay. We have INP. We have OMG. BBQ, what is up with all these metrics? Somebody, by the way, if anybody comes up with a metric called BBQ, that would be awesome. Okay, let's rewind a couple years, 2 years back. Let's say I'd actually given this talk in 2020 around modern metrics. What would we have been talking about back then? Honestly, probably mostly the same metrics. Core Web Vitals was just coming out. People were interested in learning about largest contentful paint, CLS, FID. No interaction to next paint. That is kind of a new one that we're talking about a little bit this year. Rewinding a couple further years, Perf Matters back in California in 2018. Some of the metrics we talked about, time to first interaction, time to interactive, first contentful paint. I don't know if anybody remembers the first meaningful paint, long tasks, stuff like that. A lot of acronyms. Jumping back even a few further years, back to the last Velocity that I went to here in Amsterdam in 2016. We were talking about measuring single page apps, SPAs. How you'd measure the performance of CSS. Speedy, which is an acronym I love, it just sounds great, rolls off the tongue. How CDNs can affect your performance, how you can use CDNs to improve it. And we were still to this day measure page load time, PLT. It's a very metric that's been with us for a very long time. Let's jump back to the very first velocity that happened back in 2008. I did not have the opportunity to go to this, but looking at some of the summaries that people wrote back in the day, we were talking about DNS time, XHR timings, TCP timings, RUM, the first vestiges of real user monitoring were back then. And I just wanted to give a shout out to the High Performance website book that came out from Steve back in the day. It really got me into web performance and being passionate about it. But this was all the kind of hot topics back in 2008. Going back even a few further years, at the very beginnings when Netscape was king of the land, we were talking about things like ping time, kilobytes transferred, and even round trip time, right? So very simple metrics. Metrics evolve, that's the whole point. The whole point of this talk is that metrics evolve over time. There's always gonna be something new and latest and greatest. Let's take a look at them. So let's jump back to the future. Now, I did some research. I did some investigative research, and I figured out actually how metrics are created. Every year, there is a metric minting committee that gets together. They think about what new metrics we're gonna create. First thing you gotta do, step one, come up with a cool sounding TLA. TLA is a 3-letter acronym, right, TLA. Step 2, step 3, we're good. We got a new metric. Let's talk about it, let's look into it. I mean, obviously, I'm very simplifying things here. There are some very smart people that come up with metrics, and Chrome team, other browser developers, out there do a really good job of thinking through what matters to people. So, fast forward to the year 2030, 10 or how many, 8 years from now. TLA, 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 we're gonna have all these amazing new metrics, right? We probably will. Maybe not, maybe we'll run out of acronyms by then, but there'll still be some TLAs. It gets tiring, all right? So if we look at the current landscape of metrics, what we have today, we have networking focused metrics. These are some of the older school ones. Your DNS, your TCP, your SSL timings, round trip time, time to first byte, from the point of view of the network. You have browser focused metrics, page load time, total blocking time, kind of measuring what the browser is doing itself. Visual metrics, all the paint timings, first contentful, first meaningful, largest contentful, time to visually ready, speed index. Well, they all measure the visual experience of the user. And then lately we've been doing a lot of user experience related metrics. And this is really good, I think a good evolution for all of us, but measuring how the user is reacting to the site, maybe how they're feeling, We have things like time to first interaction or time to interactive of the page, cumulative layout shift to measure, frustrating things that are happening. FID and INP, again, core web vitals, and even rage clicks, how often the user is rapidly clicking on one thing because they're getting frustrated. So why do we have so many of these? There's a lot to choose from. I don't encourage anybody to track them all for their websites. You really need to kind of narrow down to figure out what matters to you, to your business. New metrics will come every year, right? Something new to track. I love tracking things. That's my day job. I love tracking things. But why should any of you care about any of these at all? So I want you to lean in. I'm going to tell you a secret. I'm going to ask the video to get cut off. It shouldn't be recorded. It's going to be redacted. Seriously, lean in, lean in. Here's the secret. That's the best metric. It's the best metric out there. Of course, I kid. There's no one metric, right? There's no one perfect metric that you should measure or that you should measure or that we should all measure. It really matters to measure the things that we have this wide variety of metrics. Compare them to other things that you do care about. Right? So depending on your website, depending on your business, you may care about traffic, how much traffic you get to your website. You may care about conversion rate or retention or number of ads served, number of dollars in your pocket, essentially, at the end of the day. We can compare a lot of these metrics to some of these business metrics. Maybe there's a correlation there, and maybe you could see if you can improve some of these metrics that some of these business metrics may also improve as well. So if we're talking about metrics in the year 2022, what are the latest shiny things? Core Web Vitals obviously is a very important thing for a good reason, I think. The world is evolving, and we should too, but we need to evaluate all these metrics in the real world. So I'm going to be talking a lot about Core Web Vitals in a second. We have a lot of data that we've captured as part of our product, part of the Impulse Real User Monitoring. But before I get into that, I do want to spend just a few minutes to talk about the data itself. So a lot of this, we measure a lot. We measure billions of experiences every day. And the data that I'm going to present to you is from my point of view, from our point of view. All data has biases built in, caveats that you should understand. And I'm going to go through each of these so that you can understand when I'm telling you things, maybe you should believe me, maybe you shouldn't believe me, maybe this is important to you, maybe it's not. But let's cover all these things. So the first important thing is that this kind of data can be measured in several different ways. Synthetic from the lab, things like Lighthouse, PageSpeed Insight. These are great. They hold a stable environment for all your metrics. You have access to more data in the lab than generally you do in the browser. You compare that to RUM, real user monitoring. This is measuring people in the real world. It's a reflection of the real world, of what's actually happening out there. The RUM browsers only have access, to some of the data that Synthetic does. And to illustrate this point, there's a web page that we have on the right-hand side. We can see the web page loads. On the far right is a gauge that is showing us how much cumulative layout shift has happened over time. You see when the page first loads, there's a very little amount of CLS. It's a small green bar. And it's not actually until the user, ends up scrolling down the website that we see the page actually shifted. There's some bug in the site and it's deleting a lot of content or something, and the CLS value goes up. And the thing I want to illustrate here is that depending on when your synthetic tool or when your RUM tool is measuring things, you may or may not be actually capturing that negative experience. In general, as we saw in the last deck and in previous slides from Katie, lab measurements may only measure up until the page is loaded itself. So they may miss in-page interactions that are causing bad problems like this. Same thing for RUM, honestly. Many RUM providers only measure up until the page load event, and then they stop measuring. So it really depends on the tools that you're using and how you're measuring things, whether you're going to be able to capture negative experiences like high amounts of layout shifts. All data that gets presented has been measured by something, and the library, the tools that you use are important. I have a bunch of libraries up here from different companies and open source tools. We have Web Vitals. These are all RUM measurement libraries. We have Web Vitals. I work on a project called Boomerang, as mentioned before, with a bunch of other great people. It's an open source project that measures RUM. But there's other things like Lux from SpeedCurve. There's an open source library called Perfume. Google Analytics will do RUM measurements for you as well. Not a conclusive list, but some of the ones I know about. Each of these tools will measure things slightly differently. Like we're all using the same APIs in general, but they may measure a little bit more data here, a little bit less data there. So it's really important to understand kind of where this data is coming from. I would expect most data collected by most of these libraries to look very similar, but there's going to be small, minute differences that are maybe hard to pick out. The other important thing about when you're measuring things is when do you stop measuring? And that's a big challenge for RUM these days. We generally send our beacon full of the performance data at the point the page loads. And as you can imagine, things happen after the page load. People scroll, people click, people interact. So a lot of the data, a lot of the RUM libraries out there will only be measuring largest contentful paint, interaction to next paint, CLS up until the page load event, and maybe not any further. There are ways of measuring more. Other tools may measure up until the unload or till the page is hidden, or they may send multiple beacons. Most of the data today that I'm going to present to you has been just measuring up until the page load event. All data has dimensions. Dimensions are ways of slicing and dicing the data. So what browser it is, or what device type it is, or what geolocation it is. And depending on the data that's presented to you, you need to understand where that data is coming from and what aspects you're looking at. As an example, browsers. All RUM data is associated with the browser that it came in on, right? In our RUM data, in the Impulse RUM data, we generally see a lot of Chrome page loads because that's the most popular browser these days. So between Chrome and Edgeium, we get around 82-ish% of our data is on a Chromium-based browser. And so the data that I'm going to show you is a very Chrome view of the world. And that's not to say we can't slice and dice it by the other factors as well. But one of the challenges with measuring things like the Core Web Vitals is not all browsers support all APIs. So on the right-hand side, I show can I use for the 3 Core Web Vitals. And essentially, Chrome supports all the Core Web Vitals, but the other browsers may not. Safari doesn't support any of them, so none of the measurements I'm going to show you are from Safari. And Firefox is only supporting of the event timing APIs, which is things like first input delay and interaction to next paint, parts of it. So again, a lot of the data that I'm showing you is very Chrome biased, very Chrome based. Pages are built differently. Some pages are MPAs or multi-page apps, the old school way of building things. Other websites are built with SPAs. And as I was talking about before, it really depends on the measurement tool that you're using, whether it's synthetic or a different RUM library, whether or not the soft navigations that can happen within an SPA website are measured at all. So RUM, for example, can often split our measurements, not only for the initial page load, what we call the hard page load of a SPA website, but we can also split the measurements across all soft navigations that happen as well. So these are all the interactions that you're doing, all the route changes that you're doing. And so, for example, RUM data can split cumulative layout shift by each of those soft navigations. And we measure both as part of our data set. Time matters a lot in the data that you're presenting. So on the top chart, I have cumulative layout shift across all of mPulse. I'll go into more details about this later. From 2 years ago, bottom chart is a month ago. And we can see a good shift of data. This is a histogram. I'll show you how to read it later. But essentially, the data has shifted better over the last 2 years. In general, we were seeing 75th percentile at about 0.28 for cumulative layout shift 2 years ago. And now it's in the 0.21, which is more in the needs improvement range instead of the poor range. So time changes everything, right? It depends on when you're presenting the data. The time of day that you're looking at for the data changes. So this is, if you look at the reddish line there, that is cumulative layout shift split by each hour of the day. From 0 to 23, UTC, I believe. Is it UTC? I can't remember, sorry. I put it in the note down there, EST time zone. There's minute differences here, but we can see as the day gets a little bit later in the day from our data, from our mPulse data, we see the cumulative layout shift value go up a little bit. And this is looking at a data over a month, so a lot of data combined here. That could be because of different things, traffic patterns, different websites are being visited later in the day versus earlier in the day, doing stuff at work versus not at work. But the time of the day you're looking at matters. And so does the day of the week. Weekends often have different traffic patterns than weekdays. We see a similar, small, but we see a similar difference in CLS values by day of the week. The weekends, for some reason, are in our data showing a little bit higher aggregate CLS values. Okay. The last thing that matters when talking about data is who is presenting it to you. Right, data is in the eye of the beholder, as we can all see this wonderful golden white dress over here. Who am I anyway? I'm just a computer science guy, that's all. I got a bachelor's in computer science from University of Michigan, go blue. I am not a data scientist at all. I work with a lot of great data scientists. They have seen this data, they have helped review it with me. But I'm presenting this from my point of view, and I am biased in my own ways, so please understand that. Okay, let's get back to the data, because the data is the fun part. Core Web Vitals. There's going to be a lot of charts ahead. I'm going to try to explain how I would interpret these charts to you. Please ask me later if you want to talk about any of these in more detail. I don't know what I'm saying. I'm fairly knowledgeable, but I may not get everything perfect, so please take that into consideration. Now we're going to jump into the data portion. So I'm going to be talking about each of the Core Web Vitals from our perspective, from the mPulse perspective across all of our customers, and dive into some specific details as well. We're going to start out with cumulative layout shift. So as we actually saw this chart earlier today, we have the recommended range for good CLS under 0.1, under 0.25 being needs improvement, and over that is poor. So less shifts, the better the user experience. This is a histogram, a distribution of all of the cumulative layout shifts we see across all of our customers. So what is this? How do you interpret this? For those that understand this, please bear with me a second. I just want to cover some basics. On the x-axis, on the bottom axis, we have a scale from 0 to 2. The width of the bucket, the width of the vertical lines, is about 0.02 CLS wide. So this is showing cumulative layout shift bucketed by the value of CLS. The y value, then the height of the bars, is the frequency in our data that we see CLS values within that range. So the higher the bar, the more frequently that bucket gets hit worth of data. I include a vertical line at around the 75th percentile, because that's the percentile that we measure core vitals at. And there is some fine print for all of this data at the very bottom. So this is RUM data, not synthetic. This is RUM data, data that we measure from the real world. For our mPulse customers, we have thousands of customers that we're measuring this from. We measure this data from Boomerang, from an open source library. We are measuring all different types of websites, including soft navigations in this. We generally measure everything up to the onload event. So if things happen after the onload event, we're not representing it in this data. This is sampling 1 week of data, so 7 full days worth of data. It includes all browsers that support cumulative layout shift, which is just Chrome. Bucket size is 0.02, as I mentioned. There's about 25 billion or so experiences contained within these bar charts that you see, sampled on several thousand websites, and I am the one person talking to you about this. So those are all the caveats. If you would like some more details, I did blog about this 2 years ago when I couldn't give this talk 2 years ago. Some of this data has changed since then, and I hope to do some follow-ups, but you can get some more details on nicj.net, and there's some links to some articles there. So if we get back to the data itself, histogram. What we see in our data across the web, across all of our customers of mPulse, we're seeing the 75th percentile of cumulative layout shifts land at about 0.28, which is in the poor threshold. This is for 2 years ago, 2020 September. Let's compare that to last month. So fast forward 2 years. See the chart has changed. In fact, the cumulative layout shift has gotten better over the last 2 years, and I think a large part, obviously, due to the focus on core web vitals and the effects that it has on search engine rankings. But as of last month, we're seeing CLS values across all of our customers at about 0.21, which has been an improvement. If you take a look at before and now, left, or right. I feel like I'm an optometrist, like going back. Which one's better? Left, right, right. Okay, so this is today. Anyway, so things have improved. I think that's fantastic news for the user experiences in general in the web. In fact, I tried to plot the change in cumulative layout shift over time. This is a animation. Every second represents about 5 days or so, I think, for the last 13 months worth of data. I don't have data going back 2 years, so I can't show the shift from the 0.28 down to 0.21, but it did happen, trust me. The interesting thing is that it also shows that cumulative layout shift changes day by day. Again, different traffic patterns, different days of the week. It's not a very, just sticks at, one metric. Every few days it's shifting around, not a huge range. But we're starting, this is the beginning of 2022, and it's wobbling around that range a little bit. So we can slice this data by other dimensions as well. We're going to take a look at desktop versus mobile, and we actually see quite a different experience. So we're going to stick in the world of 2022 now, as of last month. The top chart here is desktop user experiences. The bottom chart is mobile. And we can see that they're actually quite a bit different. Desktop is at about 75th percentile of about 0.17, and mobile is almost double that. So in general, mobile user experiences are getting way worse of a user experience. We can look at this data sliced by industry. So I have 3 different industries represented here. The very top row is retail, middle row is travel, bottom row is news. Slicing it by another dimension, which is time. On the left is 2 years ago, on the right is today. So let's take a look at 2 years ago. On the left, we have retail on top, travel in the middle, news on the bottom. I'm sampling 5 or more websites for these charts of our customers. I'm not going to tell you which. At least 5 websites, so a decent sample, not a huge sample. But we can see dramatically different patterns for these samples of websites in these industries. In fact, as you can see here, some of our travel customers were not having the best time back in 2020. They were showing a lot of layout shifts for whatever reason. Retail was better than that, and news was, kind of in the red range still. Fast forward to the right-hand column, as of a month ago, everybody's improved, which is great. In fact, I think news improved the most from the red column to the very cusp of being green, so almost at 0.1. Travel's improved quite a bit, but they don't have so many shifts over the 0.25 range. So in general, we've just seen things improve over the last few years. Okay, moving away from distributions, I'm going to show you a correlation chart. Correlation what? Very similar to the last chart, ever so slightly different. On the x-axis is still the bucketed ranges of a metric. So on the bottom is CLS in this case. On the right axis is the timer or metric that we're going to compare it to. And so in this case, it's page load time. If you take the intersection of the two, then you get to understand how these metrics kind of correlate with each other. The sizing of the bubble here matters somewhat. It is the frequency at that particular thing. So a larger bubble means more experiences happen there. And I do include some correlation numbers on the chart as well, and a line in some cases. The R correlation, basically, the closer to 1 or -1 that it is, it means it's either more correlated or negatively correlated. R value of 1 means for every increase of 1 of CLS, you'd see an increase of 1-ish of, or whatever, of page load time, right? So in this particular chart, if we're taking a look at it, we're comparing cumulative layout shift to page load times. This is across the web, across all of our customers, and we actually see a decent correlation here. Correlation is not causation, obviously, but we see as CLS increases, we are generally seeing page load time increase as well, or the opposite. Seems somewhat logical. The more crap you add to your page, the more that crap is going to shift things down, right? Maybe if you solve for one of them, you might solve for the other. Again, the correlation is not causation, but it's an interesting metric to look at. We track another metric in Boomerang called rage clicks. This is if you repeatedly click in the same area because you're frustrated, maybe it's frustrating user experience. We're measuring CLS versus rage clicks, and we see a very similar thing here. As you increase in CLS values, the more the page is shifting, the more likely our users we're seeing are clicking really hard because they're very frustrated. Not as strong of a correlation as page load time, but there's some outliers, yada yada, but it's okay. Now I'm going to dig into a few individual websites. So we were looking at aggregates before across all of our data. I have unrandomly selected very specific websites to make a point out of some of our customers. I will not identify them by name, but I'm going to be referring to them by their industry and website number 1 or website number 2. Another chart, again, cumulative layout shift on the bottom, bounce rate on the left. So bounce rate is whether or not you go to a page and you leave and you never come back, right? You don't want to bounce. You want to keep people over time. So for this one particular website, we see a fairly strong correlation between larger cumulative layout shift scores leading to higher bounce rates. Especially as you get further right on the chart. If you're having shifts that are 1, which means a whole screen's worth, or 2, which means 2 screens worth of shifts, I don't know why you would ever do that. But we are seeing bounce rate increasing. This is landing page CLS. So the very first visit, if you're just shifting around a lot, we are seeing people bounce more frequently. It's not just that simple. Some data on the left-hand side may be a different page group, a different type of data is represented there. Maybe your error pages don't have any shifts for some reason, or maybe they do. And so you can't just look at this and say, oh, if I improve CLS, my bounce rate will go down, but it gives you a starting point to understanding whether this metric may or may not be important to your website. And maybe bounce rate's not important, who knows, but as one example. A second retail website, example number 2, shows a very similar thing. As we increase cumulative layout shift, we actually see a decently high increase in bounce rate as well. In contrast to that, here is a news website. In this case, we see some interesting patterns at the very low end. Maybe we don't have a ton of data there. But we don't actually see much change in CLS, in bounce rate as CLS increases. Once you get into the red zone, you're just essentially in the red zone. Your bounce rate's between 75 and 80%. And so maybe for this one customer, this website, CLS doesn't matter so much after a point, right? Go ahead, shift the page 20 times. They're not going to leave you. I kid, of course. Okay, that's CLS. Let's jump over to largest contentful paint. A good value of LCP is under 2.5 seconds. Needing improvement is under 4. We're going to look at some of the same types of charts for LCP from our mPulse data. Here we see a log normal distribution of largest contentful paint across all the web, across all of our customers, 75th percentile at about 3.3 seconds, which is in the needs improvement range. More work could be done here, obviously across the web. Slice and dice by the same device type, so desktop on top, mobile on the bottom. And again, we see vastly different experiences between desktop and mobile. Desktop is leaning towards, getting towards the golden realm, the green realm, at about 3.1 seconds at the 75th percentile, whereas mobile is right on the cusp of being bad. It's 3.9 seconds. So your experience matters by the device that you're using, which seems obvious, but it's good to enforce that point. Looking at the same three industries as we did before, this is for just this year. We do see some divergence. So again, this is sampling at least a few sites, at least 5 or more sites for each of these industries. Retail on top, travel in the middle, news on the bottom. They all kind of sit in different ranges of LCP. Our news example websites seem to be doing a fairly good job of presenting their largest contentful paint in the green zone, whereas some of the travel websites seem to be still leaning towards the red zone, and they could improve a little bit further. Okay, I included this chart, but I don't want you to pay attention to it at all. I actually wanted to show this chart as something that I generated, and I was like, what is going on here? This is largest contentful paint versus page load time. And this is actually a good example of data and your measurement techniques biasing your data. So what it's showing is that as largest contentful paint goes up, page load time goes up. That seems somewhat logical. Very strong correlation according to this data of 0.94. What's actually happening here is the way that we measure largest contentful paint is after the page is loaded. If largest contentful paint had happened, we include that on the beacon. If largest contentful paint happens after your page load event, we don't include it on the beacon, so it's not here in the data. So all this is showing is that if you have a largest contentful paint time before page load, we will represent it in this data. So when you're looking at data, you really have to think through all the different ways that your data could be biased. Are you sending it with this tool versus that tool? Are you measuring beyond just the page load event? Are you waiting until the unload, et cetera? So again, don't take too much stock in this actual chart itself. And there's some weird patterns there too around, I don't really know fully why the data narrows down at several stages. I think that's just a reflection of our customers. They have more popular, LCPs happening in the 2-second range and the 6-second range for whatever reason. Going to a different chart, looking at rage clicks again. We see a very similar thing to what we saw with CLS. As your largest contentful paint time increases, the number of rage clicks increases as well. Decent correlation there. You can imagine that as the page is taking longer to load. The user's getting more frustrated. They're trying to figure out, can they scroll? Can they interact with that thing? So we see a decent correlation between the two. Okay. Going to look at individual websites again, not randomly selected by me. I'm trying to make a point. This is 3 different websites. Largest contentful paint for these particular websites versus bounce rate. So again, bounce rate is how quickly they are to leave. I would say for these 3 websites, LCP doesn't matter as much. There's some interesting patterns on the left-hand side in the green zone. And in fact, all 3 websites have a different pattern of some of them slope downward, some of them slope inward, one of them slopes upward, downward, upward. And that's just the patterns of those pages. My guess is each of these websites has a very particular type of page that has a very fast LCP, like an error page, I don't know, like a order confirmation page or something like that. And you're seeing more of those pages represented in the lower values, and those ones affect the bounce rate in different ways than your other pages would. But if you get into the red zone, into everything beyond 4 seconds or so, most of the bounce rates for these pages don't change very much. And just to reinforce the point, I'm just showing one business metric here. You may have other business metrics that you care about. Number of ads served, yada, yada, revenue. Measure what you want, not against my metrics, but against the metrics that you care about. First input delay, everybody's absolute favorite metric. Good times underneath 100 milliseconds, needs improvement times under 300 milliseconds. Across all of our data, as I think we've all talked about, the world is rosy. 75th percentile is 92 milliseconds, so that's in the good range. Yay us. If we look at this for desktop and mobile, we do get a different experience. Desktop is, FID is very, very fast. Mobile, less so. I'm not showing a chart here for tablets. We do, in our data, segregate between desktop, mobile, and tablet. We don't have a ton of data for tablets, so I didn't want to include that in these slides. The majority of our traffic is classified as desktop or mobile. If you look at first input delay versus page load time, and again, we're only measuring the first input if it happened by the page load here. So if the first input, page is loaded, first input happens, it's not in this data at all. But we do see a decent correlation. As the page load time increases, you're loading more stuff. It seems somewhat logical that your first input delay may be delayed by that stuff that you're loading. Individual websites, let's take a look at this. In this case, there is one customer that I wanted to point out. The top chart is bounce rate, the bottom chart is session length. Session length just being how many pages the user visited. There's not as much interesting data once you get it above an FID over 300 milliseconds. It seems like the bounce rate and the session length essentially stay the same at that point. But if you're looking at some of the lower pages, the data from the 0 to 300 milliseconds, the green to yellow ranges, there seems to be a decent correlation, a positive, a negative correlation between higher first input delay increasing your bounce rate, which is what you don't want, or increasing the session length, decreasing the session length as first input delay goes on. So this site may want to look into FID a little bit more, particularly for the lower ranges, to see can they drop some of those yellows down to green, right? Can they increase the bounce rate by fixing some of the pages that there's a range of yellow there? Can they get them all much lower? Look at your data is my point. Versus these two other websites, data's all over the place. I would say for these websites, it doesn't really matter what you're doing for your FID. It's generally around the same bucket. There's some minor interesting patterns on the lower range of this, but the data is just wildly all over the place. FID does not, in fact, the correlation line for the bottom chart was like vertical, like it didn't make sense. Okay. Last topic is interaction to next paint. I don't have any data for it, sorry. We're going to start measuring it soon in Impulse, and I hope to share whatever data that we find in similar formats at some point, but we don't have data quite there yet. But if we were to look at the three core vitals that we looked at for Retail 1 website. So the first chart here is CLS. The chart on the right is LCP. The bottom chart is first input delay. Which ones of these matter to this one website? I would, taking a look at it, I would say there may be a case here, if bounce rate is important to them, to look at CLS, which is the top left one, because they had a decent correlation with bounce rate. The higher the shifts, the more likely the person is to leave. Same thing with the bottom one. First input delay for some of the data might be interesting. They might be able to reduce some of the bounce rate for that kind of lower range, under 300 milliseconds. Reducing those further might reduce the bounce rate for this website. LCP, again, for this site, I don't think it's really important. If bounce rate is their metric that they really care about. There wasn't a strong correlation. It's pretty much a flat line, a bounce rate, no matter what. We're seeing 28-second LCP is not really changing the difference between a 4-second LCP, according to bounce rate for this one website. People really want to buy their shoes and they're willing to wait for it to be presented or whatever it is. I'm not saying this is a shoe store, I'm discussing. Okay, with this awkward segue, how can you evaluate a metric? How can you, not me, you evaluate a metric? I presented a lot of data here. It is our data. It may or may not make sense to you. You're going to have your own data. You're going to have your own metrics that you also care about. I would encourage you to try to measure these things on your own. So if you want to measure data from a RUM perspective, there's good open source tools. There's many companies here included that will help do this service for you if you want to pay for it. Same thing for synthetic monitoring, which can help measure different types of data, right? You can do some of these things on your own with things like Lighthouse or web page tests. There's great companies here as well that will help you with your synthetic monitoring. There's other people that you can listen to. There's developer evangelists all over looking at this data. They're writing research papers. They're people like me that are giving talks. And there's some public data sets as well that you can look at for looking at different data. We have things like the HTTP archive. We have things like the Chrome User Experience Report, which provide a good public set of data that you can look into, maybe do some of this type of research, see if these things are important to you. So along those lines, what I wanted to announce today is that we are working on a project called the RUM Archive. So rumarchive.com. Our goal is to publish our data into a public data set as well. So any of you can also look at it. We're going to do it very similar to what Crux does and HTTP Archive does. We're going to put it in BigQuery. You can issue your own queries against this data. A lot of the charts that I showed today, you'd be able to generate on your own. Not all of them, but a lot of them you'd be able to. And we want this to be an open project. We want it to be a community project. Any individual, any corporation, any other RUM provider may want to publish their data as well. And the benefit of that is that you would see a diverse set of data. If you were a researcher, if you wanted to look into this stuff, you could compare the mPulse data to some other websites' data or to some other RUM providers' data. So it's open source. The description of how to publish this data, the description for how to query it, et cetera, we have all available on rumarchive.com. Very work in progress still. Some of the things aren't quite working, but we would love to get some feedback about this project and to see if it's going to be useful. Again, we were inspired by these existing archives of data. We think we're going to be complementary to that as well. But I would encourage you to take a look and give us some feedback, please. Here's an example, really quick, of a query that you could run against this public data set. So this is in BigQuery format. This is splitting data by country and calculating the percentiles of page load time for 0th percentile, 20th, 25th, 50th, 75th, 90th, 95th, and 100th percentile. And taking a look at that splitting by country for a full day's worth of mPulse data. And you would get after 10 or 20 seconds or so, you can get a result like this, which sorted by most popularity for our customers, showed a median page load time in the US of 1.8 seconds or so. So rumarchive.com, please visit and give your feedback. And that's all I have for today.
Nicely done. Early feedback without playing with it at all is that RUM Archive is awesome. I just love the idea. That's a killer idea. Yeah, haven't even touched it. So kudos to you for calling out the data, bias stuff at the beginning, because I think that's one of the things that, it's a challenge, right? Anytime we talk a lot about the importance of measuring performance, but then interpreting that data is a pain in the butt, and sometimes it feels like that requires a whole individual or a whole different team itself. Do you have any advice for folks that are trying to do this kind of analysis inside their own organizations? Do you need to have data scientists sitting by your perf tools? Do you need
No.
How does this work?
It helps, certainly. I have a great team behind me that looks at all this data with us. They help double check my work and make sure I'm not talking about silly things in front of everybody. Start with the basics. Start by measuring just one or two of these metrics. See which ones correlate with the things that you care about. Start diving into the data. If you can slice and dice it by different dimensions, that can often help you go down different paths of, oh, this type of page looks more challenging from a CLS point of view. Maybe I should look into that more. You don't need to live and die by these metrics. You don't. They can be indicators of a problem or good things, and you can use that to then continue your research, continue your focus of where you're going to make changes, right? Where you're going to put your energy. So be skeptical is a big point of it. I showed you a chart that looked really interesting, but once I started diving into it, I was like, oh yeah, this is just a side effect of how we measure things in the first place.
On that line of being skeptical and stuff like that, you mentioned offhandedly the situation where shifted 20 times, they're not going to leave you. What do you do in situations like that where I think everybody in this room probably is bought in that performance matters. Yeah. But then you do the digging and you find that it looks like this metric doesn't seem to correlate in any obvious way. What's your advice to folks who are still they've got the hunch, they've got the skepticism that, it matters that we've got a 28-second LCP, but I can't show the business correlation?
So I would say, I have a couple answers to that. I think it's hard. So we have a lot of customers that, pay for us to measure this data for them. the first question after looking at a chart or an interesting thing like that is, okay, great, but how do I fix this? Where do I go down to understand more? And I think one of the challenges, especially for like some of the outliers, is how do I repro that? Like, how do I get back to that in the first place? How can I use my local developer tools to emulate what I see in these charts? And the simple answer is you usually can't directly. Hopefully, based on the data that you've captured, all the different dimensions, was this a Chrome browser on Mac, in the UK? Maybe that might help narrow down kind of what you're looking at. And then, hopefully you can get a repro from that. Maybe, maybe not. It kind of depends on the tools that you're using, how much data you're capturing, how much supporting data is there. Things like for all these core Web Vitals, all the attribution data, like that we were talking about, Katie was talking about for the Web Vitals package. We have very similar things in Boomerang, where we're capturing not just the number, but the thing that caused the number. So the element that shifted or the image that caused the LCP. Looking at that data might help you narrow your focus at least, and maybe solve the problem that you're looking at.
And I think the comparing data across different tools is always it's an obvious challenge because of all the things you pointed out in terms of measurement and stuff like that. One of the more obvious ones I think that people are going to be potentially questioning after seeing that, where the emphasis on core Web Vitals and particularly from the industry as well is Crux versus that.
Yes.
So what are some of the key differences in terms of how Crux is collected?
Absolutely. So in the data sets that I was presenting, obviously Crux is Chrome, just Chrome. Well, most of the data I presented was also just Chrome because that's the availability of the measurement APIs. If you're looking at some of the other metrics like page load time or some of the other things that we capture, obviously that's beyond just Chrome. Comparing Crux to any RUM package, Crux is generally measuring the full page load experience up through the unload event. Most RUM providers only measure up through the page load event and not afterward, or you have to do some configuration to get more data, so you often see differences with that. One of the benefits of using RUM for some of this measurement is that you can slice and dice by a lot more dimensions than Chrome gets you. So you can actually look by page group or by URL, what are your layout shifts or whatever metric is important to you. So you have some less, they're not always going to match up, but you may have some more flexibility with RUM data to understand a little bit more. Especially for things like soft navigations, for example. When you're doing an in-page, in-route change, we can actually split your CLS values by each of those. And that might help you focus on, narrow down to like what is the actual thing that, the navigation that caused the shift.
Okay. And one last one then before lunch. Again, you brought this on yourself by bringing up all the differences in terms of like biases in data. So you had people really, there's quite a few questions. I'm sure people will catch you with like their theories on some of the stuff that you were showing. But one of them that was the CLS comparison from 2020 to 2022. Yeah. And do you have a sense, because there was quite a bit of improvement in change to that metric, both in terms of how it was reported and how now arguably cumulative layout shift isn't really cumulative anymore because of the window thing. Right. So like, do you have a sense of how much of that is like we've improved things on the web and how much of that is like the metric itself?
Well, and for us, we are still reporting CLS up to the page load.
Oh, okay.
Well. So we are not doing the windowing yet in the data that you're looking at there.
Okay, so that's not based on the 5-second window.
Correct.
Okay.
Yep.
Okay, cool.
Yep, for us. So it more of an apples-to-apples comparison. For our data as well, not as many people were measuring CLS back in 2020, so smaller data set versus a larger data set. So some of the websites may be biasing that as well. Like some of our customers that onboarded to measuring CLS may have shifted it as well. Yeah.
Okay. All right. So that definitely accounts for at least some of the variability for sure. Yeah. Okay. Awesome.
Yep.
Thank you, sir.
Thank you.